Why don't we have a 128-bit computer? The quick and dirty answer is that there is no need for such a computer architecture. The 64-bit register can hold up to 2 to the power of 64 different values. That is 18 quintillion numbers, or 1.8 times 10 to the power of 18, or what is equivalent to 16 exabytes of RAM. From an arithmetic perspective, that value is larger than what is needed numerically in our daily lives. The main reason for the migration from the 32-bit CPU design to the 64-bit architecture was the need to increase the computer's ability for accessing RAM beyond the 4 gigabyte barrier imposed by the 32-bit system. From a practical side, we did not need the full 64-bit register to access the max RAM capacity of the current processor, but all that was required was the extra bytes beyond the 32-bit limit, and that has been more than sufficient to grant us ample RAM capacity for our current generation of computers. That development and change in design has elevated the pressure on us from pushing or implementing the 124-bit computer architecture anytime soon. Currently, the biggest obstacle that modern computers have of reaching the maximum RAM capacity are the limitations dictated by the operating system design or the physical limitations imposed by the hardware. Here's an interesting fact for you. So even if RAM prices did drop to $1 per gigabyte, which is really cheap by today's standards, at that bargain price, an exabyte of RAM would still cost you more than $1 billion. Even though modern computers technically are 64-bit processors, they are still able to process integers, floating point numbers, and vectorized numerical extensions in 128-bit format natively for uses other than RAM operations. Values larger than 64 bits can be found in applications like encryption keys, floating point circuits of graphic cards, or graphic subsystems, primarily to improve multimedia performance like video encoding and decoding of different video formats like MPEG. These days, registers larger than 64 bits are also used to execute operations on multiple data values simultaneously, or in operations that require copying or moving large amounts of data, like files on a hard disk or network traffic. What the future brings technology-wise, we may never know, so we can't really say that there will never be a 128-bit computer. Jumping from 8-bit to 16-bit CPUs was dramatic and came with big improvements, but jumping from 64-bit to 128-bit CPUs might not be that significant of an improvement compared to the previous CPU designs. Other obstacles that can hinder the development of a larger bus in computer processors are the constraints imposed by the materials involved in manufacturing the CPUs. But even if we were successful in overcoming those hurdles, manufacturing a 128-bit computer can prove difficult, because you have doubled the bus width that goes from the CPU to the peripherals. And that creates new challenges and logistics of how those extra bus lanes are going to reach their destination connections design-wise. Not only is the bus layout and design going to be difficult, but also the physical size of the CPU and the dimensions of the motherboards are going to be increased dramatically, making the manufacturing process more resource-intensive and cost-prohibitive. If you liked this video, please don't forget to like and subscribe.